By 2040, the industry is going to turn around $850 billion. Is India ready for this quantum shift?
India is definitely ready for this.
Can this actually turn into reality?
Think of teleportation.
Real world cases of quantum computing.
It stems from Feynman's idea about simulating nature using the laws of nature. We have expertise in nanotechnology also.
Do they have future in India?
It's not just one field, it is an interdisciplinary approach. Vast number of opportunities. It is not just involving hardware, software people is also required.
Specialization of quantum computing or MSc physics, like what kind of designations or which platforms they will be?
The big tech companies like IBM and Google who have definitely heavily invested in this.
We have recently signed an MOU as CDAC and Manav Rachna University. CDAC will provide expertise for building MSc physics with quantum computing specialization.
Why is quantum computing? What is quantum computing? Technology has always evolved in leaps. But what if the next leap isn't faster or different, but actually fundamentally changing things? आज हम बात करने वाले हैं एक ऐसी टेक्नोलॉजी के बारे में जो कि फ्यूचरिस्टिक नहीं है, वो फ्यूचर को रीडिफाइन कर रही है. Hello everyone, I am Sonal Mathur and welcome you all to the Quantum Leap episode at Manav Rachna podcast. Today we will be decoding the quantum computing secrets with CDAC experts and knowledge associates, Mr. Asher and Ms. Kanishka. Welcome to Manav Rachna podcast. As we see, quantum computing is rapidly evolving. And there are predictions by 2040, the industry is going to turn around $850 billion. Is India ready for this quantum shift?
Yeah, so India is definitely ready for this. I would say India has a rich history of in academia where we have scientists, we have academians who have contributed a lot to quantum theory in general. So we have a rich background in that regards, and now is the time where India has to now shift towards this whole new era of quantum computing. So and that we have already started actually. So in terms of infrastructure, where we have things going on, we have some experimental setups in universities which are going on, and I would say pretty much in 5 to 10 years we will definitely have quantum computers in the orders of tens at least in India, and students will have access to them. So I don't doubt that India will fall behind in this area at all. We do have the precedent and we do have the history, and government is also backing us in this area.
Okay. Sometimes when we talk about quantum computing, it looks like it is coming right out of these sci-fi movies.
Yes.
We have seen in parallel realities in Stranger Things, or you see the complex physics in movie like Interstellar. How close we are, or how futuristic the myths or the the fictional things which are being created, can this actually turn into reality?
Actually, I want to answer that. So, means what we see in movies or any fictional stories that we hear about, it's more about expanding small idea into larger fictional way. Means there is some truth to it, they just pick it up and they just make it up things. But when we come to theoretical, how we are doing everything, it's totally different. Means they conceptualize, means they take things from the small concepts and make it in a larger, bigger way to attract attention. I mean, when I think of teleportation, yes, they visualize it in a different way. Means move from one place to another. But when we are actually looking into quantum systems or anything, it's just cellular level, very atomic level. Yes, so those kinds of concepts are different. It's mostly, I would say, they are just enlarging a small situation into a very big thing.
Okay. So we can say slowly, but quantum is coming into our syllabus.
Yeah, so I would say definitely when we see movies like Interstellar, or even let's say Ant-Man from Marvel, who talks about quantum mania. So yeah, definitely they do get inspired from the known physics and everything. And definitely if you look at cases like quantum teleportation or multiple parallel realities, it has roots into the understanding of quantum mechanics that we currently have. So we do take inspiration from physics, although we are not there yet in terms of actually making a teleportation device or something like that. So yeah.
So, what are some real world cases of quantum computing which are actually changing the face of traditional computing?
Yeah. So if I look at the big picture, what quantum computing has promised us altogether from the start, is it stems from Feynman's idea about simulating nature using the laws of nature. And what I mean by laws of nature is laws of nature as in the laws of atoms, laws of electrons. And that is what quantum computing promised. In that area, we are already developing. We have already made advancements to those areas. The other sort of, I would say, the big, the trophy, I would say, in quantum computing would be the Shor's algorithm and subsequently the Grover's algorithm. So these Shor's algorithm particularly, it showed to the world that, okay, now you have a algorithm which you can run on quantum computer, let's say, and you have it, let's say, and then it can factorize all of your integers and it can break encryptions that we currently have. So definitely, yes, that's one of the area where, which is a prize for us, which we do want to advance. And there have been progress. I mean, every development that we do in quantum computing is some way or the other sort of, breaking this whole mountain of Shor's algorithm that we have. But we have been focusing on just one mountain, I would say. What we are focusing on is currently there have been sprung out even more applications. Firstly, I would say drug discovery. So something like finding the correct drug for I would say tackling a symptom or tackling a disease, or even the complex problem of solving protein structures. So we do solve these kind of problems on normal CPUs, but quantum computing provides us the advantage to sort of make this even faster and better. So that's an area where it's going on. The other case is in finance models and I would say in optimization overall in general. So yeah, there are industries which are actually which have direct application towards quantum computing, and yeah, they will definitely fulfill from it.
Okay, so we are touching the pharmacy and finance, and what about the cyber security? Like, are we quantum computing coming there all too?
The Shor's algorithm, it's based upon the idea that current encryptions work on prime factorization. Like, we cannot prime factorize a number, large number, using classical computers. It would take an enormous amount of time. Sometimes it is impossible within the small time frame. So our current cryptographic systems or cyber security based upon that encryption, means that idea that we cannot able to prime factorize. But Shor's algorithm promises that it would find the prime factors within a simple amount of time using quantum computers. The problem is that we do not have the large quantum computer systems yet, so that hinders us to do the Shor's algorithm. And if you think of it, people are actually preparing for the first quantum cryptography. What if quantum computers work? Then we have to revolutionize all of our cyber security systems. The RSA encryption would be broken, and now we have to work on those new cryptographic codes and everything. So people are getting ready for that too.
As we slowly move ahead and in the field of quantum computing, so how much load India is taking on its shoulders to move ahead, and how much India is contributing towards the world economics with regard to quantum computing?
So right now, India has a key role to play. The first and foremost will be that we naturally would be best at is algorithmic development. So India as a whole, if you look at it, we do have academicians who have been doing a lot of research into quantum mechanics, quantum theory, quantum information. Now is the time to test their theories, test their hypotheses on an actual quantum system. So one of the first things I would say that quantum computer has actually allowed us to do is it has made our own experimental quantum lab at ready. So physicists now don't have to just rely on theoretical methods. They can take their system, whatever they have, and they can actually try to simulate it and like an actual system, like how the actual system would really behave, and then they would actually test their theories even to a more higher I would say accuracy. And so yeah, India as a whole, since we already have a lot of research going on in quantum theory and quantum information, we can definitely contribute in algorithms. Another key aspect, underrated aspect I would say of India is that we do have we have expertise in nanotechnology also. So in that regards, nanotechnology, I would say, directly influences quantum computing, because if you look at this, if you look at the current famous quantum computing architecture, which is called the superconducting circuits, so that requires expertise in nanofabrication to fabricate these chips. So definitely, yeah, we have the infrastructure, and this is we have some expertise in fields, and this is how we actually see that India can contribute to world at large.
Okay. And how much CDAC is contributing towards India's development in?
So CDAC is based upon supercomputing, as we know, and we also have taken the responsibility to make quantum computing available for everyone. We have a website platform called QUniverse, which our main is to that every researcher, student who even wants to learn quantum can start there. It's not just a small. It's not just for beginners. Even the people who want to just simulate their circuits, their programs on quantum using Qiskit or quantum anything else, they can use it. So they can use the different backends. They can use it. They can just run it on a computer or a HPC system, or they can even run it on a actual quantum computer. Our systems are integrated with that. So along with that, we have a reference facility coming up, which will host a 108 quantum computer. So our aim is to that make that available for Indians, and means all over the world, so that they can use this quantum computer as well. And we have a lot of things going on.
Yeah, another key thing that I would like to highlight is, since we are experts in supercomputing, one of the core areas that we are working on at CDAC, actively working on, is HPC quantum integration. So this is an idea about quantum computer. This is an immediate application of quantum computer, I would say. In its immediate form, or whatever it is in its current form, quantum computer will work like GPU works with CPU. Okay, it assists in the computing. It makes calculations of AI algorithms much faster. So we do see that at the immediate application stage, quantum computers will be used in a way that, let's say you want to solve some kind of a drug discovery problem, or just let's say you just want to simulate some molecule, and you log into your HPC machine, server, whatever you have, you write the program, and you dedicate some part of your code towards and you tell it, okay, this should run on a quantum computer. So defining all the pipeline where we can do some part, we can take this chunk of code, execute on a quantum computer, and then have the server, the HPC system and quantum computer talk back with each other and have communication protocols defined there. So that is an area where we are actually actively working on. And I would say we would like to have a lion's share in this. So we would like to have we are trying to develop expertise also in this. Okay.
So for the students who are watching this, and quantum computing looks very interesting. Interesting तो है, लेकिन इस path पे जाना कैसे? So what are the kind of a skill set a student should have or possess so that they can walk on this path of quantum computing and take up this?
So, just because they want to learn classical, quantum computing doesn't mean that they have to stop learning the roots of classical computing. The knowledge that we are going to build for the quantum computing or quantum itself, quantum mechanics and everything, it has its roots from the classical mechanics. So the ideas, the knowledge that they would learn, it will start from there. They have to have a strong base over there. Then they will learn math, linear algebra, which has to be one of the most key features that has to be learned to understand theoretical parts of quantum computing or quantum mechanics itself.
Yeah, to add that, quantum computing brings with it the philosophy that results that we see or properties that we see in nature have some probability assigned to it. So a good idea in statistics, in probability theory, would definitely benefit the upcoming students. Also, I would say since we are doing quantum computing, so we do need a base in quantum theory itself. So understanding that from physics point of view, because if you let's say you take a student who has done his 12th and is just appearing for engineering. So in that regard, so a student with that kind of qualification, uh, he has mostly been taught physics from a classical point of view. So he has been taught about Newton's laws, he has been taught about heat, energy, thermodynamics, yes, but he has not ventured into quantum mechanics yet. That happens for students who have opted for basic sciences. It doesn't happen in detail for students who have opted to engineering. So we do need engineers in quantum computing field right now. So definitely people or students who are in engineering fields should have a background in quantum mechanics too and quantum theory. Yeah.
And how vast is the career path? Like, do students have opportunities? Because if we see immediately, if a student, Manav Rachna University offers BTech CSC specialization in quantum computing in association with CDAC. So, if student passes out after 4 years, so do they have future in India?
They definitely do. So right now we are at progress, means we are in the progress of making quantum computing available for everyone. So it is involving making a lot of software, making the quantum hardware. So it's not just one field. It is an interdisciplinary approach. We would need a computer science student. We would need a engineering student. We would need a mathematics student. We would need a physics student. So it is like they have a vast number of opportunities. It is not just involving hardware, software people is also required. So I myself is a computer science student and I'm contributing to quantum computing right now.
So when they take the specialization of quantum computing or MSc Physics quantum computing course, so where they can see themselves, like what kind of designations or which platforms they will be?
So currently what we would say to these guys is definitely if you go for higher studies, then you are doing PhD. But let's say you just graduated with MSc in quantum physics and quantum computing, you definitely have places in India in startups, Indian startups who are aligned with quantum computing, and even in CDAC as a whole. So there are institutes, there are companies who have just ventured into quantum computing and trying to develop it. So I would say positions like that are definitely open for these guys.
And apart from India, like there are...
Yeah, so apart from India, there is definitely the big tech companies like IBM and Google who have definitely heavily invested in this. I think Europe has a lot of has so many startups in like quantum computing itself. So definitely there they have a place. Also, the another caveat is that PhD and sort of a bit more expertise in this field is required to perform at any level, may it be researcher or may it be a industry person. So definitely doing PhD is a plus point, I would say, in this area. Yeah.
So how does the collaboration between CDAC and Manav Rachna University will empower students to gain hands-on experience in quantum computing?
We have recently signed an MOU as CDAC and Manav Rachna University at the recent AI Summit. As a part of that, CDAC will provide expertise for building MSc Physics with quantum computing specialization and computer science with quantum computing specialization, and we will be working in close collaboration. We hope that this would help research environment to grow a lot better.
How was your experience today at the conclave, quantum computing conclave?
Yeah, so whenever we give workshops, one of the things that I expect from the audience is that they be inquisitive, they ask questions, and today we definitely got that. So today we definitely had so this is a very, how should I say, so if I look at it 2 years back or even 5 years back, people knew about quantum mechanics, people knew about these things, but students were not really inquisitive about it. Today, if I see it in, like I would say in the past year or so even, and I think Manav Rachna especially has really great students in that regard. So we have seen, even though we start with very basics, the students are really keen to know what happens at a deeper level and how really things take place, I would say. So I think one of the things that happened in today's workshop was we were explaining quantum gates, and that is a sort of basic baby steps towards quantum computing, and they really wanted to know how does this happen in actuality. So they really wanted to know how does this happen in the hardware level, how gate application takes place and everything. So yeah, curiosity is definitely encouraged in this field, and in Manav Rachna we have definitely seen that time and again.
So any one message you want to give to the students who wish to pursue quantum computing? Like, is it tough, or is it interesting, or is it domain specific, or what it is? Like one thing, one advice you want to give to quantum computing enthusiasts?
Yeah, so I would say it's a pretty interdisciplinary field right now. Sure, maths and physics are like the bread and butter here, but maths and physics are bread and butter everywhere, in every engineering field. So I would say any student, if a student who has some expertise already defined in, let's say, CS or even electrical engineering, can definitely contribute to this field from his own field. So that's my I would say that's my advice to any student who is trying to make it in quantum computing. Start with your field, have an expertise there, and then definitely venture out and see these things. So it also develops a interdisciplinary collaborative approach towards your career, I would say.
And what you would like to add, Ms. Kanishka?
So as a student, learning is one of the enthusiastic thing they do. So quantum mechanics is a part. It's a very interesting thing. Means you are part of your you're part of your department, whichever it is, that's computer science or in electrical engineering. It's interesting, but again, going into quantum mechanics and everything, it's interesting itself. You can apply the same concepts that you learn, integrate them, and it's like a combination of two different things coming together. It'll give you self-satisfaction too.
A big thank you to both of you to help us decode all the the questions which we had, and why is quantum computing, what is quantum computing, and how a student can come forward. And to everyone watching this is your sign to start thinking beyond limits, because quantum computing is the future and future is here. Until then, keep exploring, keep innovating.